Okay, so we've got test 2 and the midterm coming up pretty soon, like test 2's next week. It's definitely the hardest of the tests out of the 4 regular old tests. So we're going to do some more practice on it today. I just posted a bunch of announcements. You can always find these in announcements. Here are a bunch of old practice tests I have. A lot of these have solutions too, like that's kind of out of order, but here's an old test 1 and there are the solutions to it and so forth. So you can see here, there are a few test 2s with solutions. So my recommendation to you to study for test 2, go here to this announcement, maybe download this file, try it on your own, and then look at my solutions. And of course I picked one that doesn't have solutions. Not all of them do. Oh yeah, there it is, right there. I don't know, that one says new. Anyways, you get my point. Try some of these practice tests. Try them in a timed environment. Like try to do the entire thing in an hour, then go look at my solutions. Your test 2, of course, is going to be just like test 1 was. It's going to be in My Open Math. It's going to be a lot like the homework. You can always go back and practice the homework. The midterm, though, and the final are going to be handwritten. So you want to make sure you know how to write up complete solutions. That's why I do so many of these group assignments and these written assessments. I want you to get good at writing complete solutions. Here is a study guide for the midterm. So we'll talk about this next week. I'm not going to go through it all, but this is all the stuff that will be on your midterm, all the list of symbols you need to know. But you kind of need to know these now, right? Kind of need to know them for the test 2. Make sure you know what all the letters stand for, all the formulas. Remember, you get to use a formula sheet on the midterm, handwritten, front and back, regular size sheet of paper. I also made up a practice midterm. Again, I would try this on your own. If I were you, remember you have 2.5 hours to do the midterm, but see if you can get this done in an hour. Definitely try to get it done in 2 hours, where you're writing up complete solutions on every problem. Then go and check out my solutions, which are posted right here. Okay, so plenty of practice there for you. If we look at stuff that's coming up, remember I mentioned this last time that there's this extra practice test that like is going to show up. It's not worth a grade. It's kind of extra credit, but it'll show up in your calendar because I would like everyone to take a look at it. If everyone in the class does it, does the entire thing except number 8. Remember I said you could skip number 8. If you do the whole thing, I'll give the entire class extra credit. But everybody has to do it. So tell your group mates, make sure they do it. Now we're going to take a look at some of it now. Looks like this. Again, I didn't write this. Whoever wrote it spelled statistics wrong. The typo right there. But let's just kind of look through it real quick. We're going to do about 4 of these. So question number 1 here, that's a chapter 5 problem. That's a test 1 problem. That's just a normal distribution. There's no sample there. It's an empirical rule problem. We know how to do that. Same with question 2. It's an empirical rule problem. Question 3, also chapter 5 problem. There's no sample. We're looking at the distribution of the entire population. We're making predictions about individuals. So we draw our picture, find the z-scores, normal CDF. Everybody knows how to do that. These questions, 4, 5, 6, and 7, though, we're taking samples. Now we're in chapter 17. These are the ones people have trouble with. I have full confidence in your ability to do number 3 here. We've been doing those forever. Now we're doing samples in these. So let's do these. Okay, so I got these a little out of order, but okay, so pause and read the question. Notice it says we're doing a sample. Now, the first thing we got to ask ourselves is this a mean problem or a proportion problem? Remember, those are completely different. It's a mean problem. We know that because it says the word average in it. If it says average or mean, it's a mean problem. They also give me a standard deviation. So my first step here, a required step, to find my variable. On the midterm, you're going to have to do this. This is required. Let mu be the mean. What are we talking about here? ACT score. We're told our population mean mu is 21.4. We're also told the population standard deviation is 1.05. Now we have a sample. My sample size, N, is 25. I want the probability that my sample mean X bar is more than 22. So, like, the question doesn't ask it, but I might ask this on the midterm or even on test 2. Let's define our model. Again, it's not necessary here. They didn't ask for it, but let's define our model. Like, you have some written assignments and group assignments where I say, give the model, this is the information I want. First, you got to define your variable, but we've done that. And we're supposed to check all the conditions. I'm never going to ask you to check conditions. Like you might have homework questions where there's like the little fill in the bubble things where you check the size condition, but that's it. Because if we don't meet the conditions, it's a boring problem. We can't do anything. If we don't meet the conditions for the central limit theorem, we just move on with our lives and there's no math to do. So what I find more interesting is saying, look, let's forget about checking the conditions. Let's do the math. And then if we get a really weird result, maybe we'll go back and go, oh, maybe we had a bad sample. I find those questions more interesting. So I'm just going to put here, check conditions. Check. Okay, so assuming we meet the conditions, by the way, the conditions are you took a good sample, it was random. Your samples are independent. The act of taking a sample doesn't affect the next sample. And that your sample size is large enough. If your population is nearly normal, you can take pretty small samples. If it's not, your sample needs to be at least 50 in these mean problems. ACT scores are normally distributed. We could have made predictions about individuals. So that size of 25 is fine. Okay, then the central limit theorem says that all the X bar, the sample means, are normally distributed with population or with mean the same as the population mean, 21.4, and standard deviation, sigma divided by square root of n. That's a sigma there, which would be 1.05 divided by square root of 25. Square root of 25, of course, is 5. So let me clear. 1.05 divided by 5, 0.21. So that would be describing my model. Again, you're going to have assignments where that you're asked to do that. So I went ahead and did it. It wasn't necessary for this problem. Now I can answer the question. So it's like with all my normal model problems, I'm going to draw a picture. Picture is required. Right in the middle, I have the population mean of, what was it, 21.4. I want to be more than 22. So here's my sample mean of 22, and I want to be above that. So I find my z-score, the one I'm asked about, minus the one in the middle, over that standard deviation I just found. Here's where mistakes happen. Not this population standard deviation, this one. If you're doing a sample, you got to divide by square root of n. So that's 0.21. So 22 minus 21.4, hit enter, then divide by 0.21. That's a pretty big standard deviation, or it's a pretty big z-score. 2.86, round z-scores to 3 places. Then normal CDF, smallest z-score, so his z-score was 2.86, all the way up. Where did I stop shading? Infinity, which of course we put in the calculator as 99. So 2.86, 99, leave these two alone. 0.002. And then, of course, we would write a complete sentence. And if we wanted to turn that into a percentage, that would be 0.2%. So we're not talking about one person getting a 22 on the ACT. We're talking about you grab a group of 25 random tests. What's the probability the average is 22 or more? Okay, here's number 4. These are out of order. First thing we got to decide, is this a mean problem or a proportion problem? If they give you percentages, it's probably a proportion problem. You can talk about average percentages. One of those practice tests that I posted in the announcement talks about the average percentage that millionaires donate to charity. You can talk about average percentages, but if you see percentages, it's probably a proportion problem. So you look around, do they say the word mean? Do they say the word average? Do they give you a standard deviation? That was no to all of those on this. We're talking about a group, and we want to know what fraction of the group, what proportion did something. So this is a proportion problem, which means our first step is figure out what our population is and what we're going to call success. I'm going to upload this. I want this to look pretty. My population is Americans. Success is they're stressed. I think we have a group assignment that's basically this problem again. Then we define our variable. We only write this here to help us write this next line. Let P be the proportion of these people that did this, or of this group that did that. So of Americans that are stressed. Okay, so we're told that our population success rate is 33%. So that means Q, which is always 1 minus P, our failure rate is 67%. 67% of the population fails. So 67% of Americans fail at being stressed. Remember, success doesn't necessarily mean something good. Success and failure are not good and bad. Success is the thing you're studying happened. Okay, and then we have our sample. We're always going to have an X, an N, and a P hat, and they'll always give us 2 out of the 3. There's my sample size, 45. I want no more than 12. Okay. How do we get P hat? P hat is always X over N. So 12 out of 45. .267. I'll go 3 places there. So the question is asking me for, I want the probability, that's a capital P, that P hat is, no, not more than, less than 0.267. One of the problems I think people have with this class with statistics is so many different words start with the letter P. We've got population, proportion, parameter, probability. I think there's another one that I'm not thinking of right now. A lot of different words, percentage, there it was. A lot of different words start with the letter P, so people get all these confused. So we use capital P to mean probability. Little p is the population proportion of success. Okay, now we're supposed to check the conditions. Again, I'm not going to make you check the conditions because like it even says here in the problem, make sure you check all the necessary conditions. On the midterm, I'm not going to make you do that because if you fail to meet the conditions, the problem's over. It's a boring problem. In the online test, they might make you click the little boxes that say N times P is bigger than or equal to 10, N times Q is bigger than or equal to 10. Just like you did in the homework. And those are both true. You can check those yourself. Okay, now let's define our model. Let me see if I can make all this a little smaller. Oh, well, a little too far there, but that's okay. I think we can still read that. Yeah. Okay, it didn't ask us to define the model, so I'm doing a little bit extra here just because I know people have trouble with this. So the model, again, we're supposed to check all the conditions. Let's pretend we've done that. Central limit theorem then says the p hats, that's what we're modeling, sample success rates, are normally distributed. I'm going to abbreviate here. With mean equals the population success rate, 0.33, and the standard deviation is, and we got to actually calculate this, PQ over N under a square root. So let's get our fancy calculator out here, clear it so we get a nice pretty screen. Oh, my calculator crashed. Hold on. Sorry. That's never happened before. So square root of P times Q 0.33 times 0.67 divided by N. I don't remember what N was. 45. Make sure you know how to type this in your own calculator. I can't stress that enough. A lot of times people don't practice these on their own. They get to the test and they don't know how to use their calculator. Your screen might look different. So that's 7%, 0.07. Okay, now it's a chapter 5 problem. It's a normal model problem. We know how to do all of these. Draw the picture. That was a terrible picture. Right in the middle, the mean is P, which was a success rate of 33%. I want to be 0.267 or below. Draw my picture, find my z-score, the one I'm interested in, minus the one in the middle, divided by that standard deviation I probably just calculated. So 0.267 minus 0.33, hit enter first, then divide. Negative 0.9. Why is it negative? Because we're below the mean. Was it 0.9 or 9? Just 0.9. Then normal CDF. Smallest thing I shaded to largest. So down here is negative infinity up to that guy we just got to. So second distribution, normal CDF, negative 99, negative. Remember, this is your negative button right here. That's the minus button. 0.9, 18.4%. And again, word problems have word answers. If I should write this out, but I'm not going to make you sit and watch me write that out. The probability that fewer than 12 of these students say they're stressed is 18.4%. Okay, these next two problems, whoever wrote up this, remember all these answers are down here. There's even all the work. There's even the conditions. Whoever wrote this up, notice they didn't show any work on 6. They also got it wrong. That's the wrong answer. I really like this question. A question like this is either going to be on test 2 or on the midterm or on the final. You're going to need to know how to do a problem like this. And it's nowhere near as confusing as it seems. So pause and read the question. Hopefully you've done that. Mean problem or proportion problem? It's a mean problem. I know that because they say the word mean and they give me a standard deviation. Okay. So let's think about this here. We're talking about putting people in a boat. I want to know what's the probability that the boat's going to sink. Each boat can hold 800 pounds, and I'm putting 4 people in there. So how much could each person weigh? Each person on average, and still be under 800 pounds. Well, if I've got 4 people, I'll write all this out. First, let's define our variable. Let mu be the mean weight of people. Actually, I think it's specifically men, or is it people? Just men, people. We're told that that is 195. Oh, yeah, it is. It's not people, it's males. See right there. I knew it was. We're told that the average, the population average is 195 pounds with a standard deviation of 10 pounds. What I want is, I want the probability that the total is more than 800 pounds. So if I've got 4 people, my sample size is 4 in the boat, how much could they each weigh? So that's going to be the probability that my sample mean is more than 800 over 4, or in other words, the probability that my sample mean is more than 200 pounds. Not that they all weigh over 200, but you put 4 people in a boat and they average more than 200 pounds. If that happens, then total, they're going to weigh more than 800 and the boat's going to sink. Okay, we're supposed to check the conditions, not going to bother with that. I should point out here, you might be worried that that's a small sample size, but weight of adult men is normally distributed. So my population is normal. I can use any sample size I want. Okay, so pretend we check the conditions. I'm not going to write out the model here. I'm just going to find my standard deviation, sigma divided by square root of n. So 10 divided by square root of 4, n, that'd be 10 over 2, or 5 pounds. That doesn't say 51, that's 5. I'll make that look more like an L, 5 pounds. I draw my picture. Right in the middle, the population mean 195. I want to be here, X bar is 200. I want to be there or above. See, here's where mistakes happen on this problem. I see this all the time. People will, I'm going to erase this, but they'll draw this. They'll have 195 here, and then they don't think about the fact that we got 4 people. They'll have 800 on here, and then they'll find a z-score. 800 minus 195 over, and 90% of the time they use the wrong z or wrong standard deviation. But let's say they use the right one. Say they use that. I want you to look at this. 800 minus 195 divided by 5. You will never in your life get a z-score of 121. If you get a z-score that big, you've done something very wrong. Like that is, like if I plug this in the calculator, look, I want you to see this. If I go from 121 to infinity, like, look, I can't even put 99 there because that's not even bigger than that. So infinity, I'll just keep typing 9s. My calculator is going to say there's a 0 probability of that. It's not actually 0, but it is astronomically close to 0. That's not going to happen because we've done the problem wrong. If you get a z-score that's gigantic, then either the point of the problem you're working on is this thing cannot happen, it's impossible, or you've messed up. But that wasn't the right way. Right in the middle, I've got the average for the entire population's 195. I want the probability that my sample average is 200 or above. Now when I do a z-score, 200 minus 195 over 5, check your math, you get a z-score of 1. You do normal CDF, 1 to infinity, that's 1586, I think. Nope. What? Oh, I keep hitting the wrong buttons. Sorry. 1 to infinity. 1587. So there's about a 16% chance that this boat's going to flip. So I like to, like I'm telling you now, you're going to have a question like this later. I like to do a follow-up question. So imagine that you go to Wet and Wild. I don't even know if Wet and Wild still exists. You go to Universal. You're in one of these boat rides, one of these river raft rides. And if the total exceeds 800, the boat's going to flip, somebody's going to get hurt. And I'll ask a follow-up question. Given your answer you just got, would you get in the boat with 3 random people? And a lot of times people will say, like I get this all the time, they'll say, oh yeah, that's a pretty low probability. Oh my God, no, it's not. That's 16%. That's 1 in 6. Imagine if at Universal, they're running one of the boat rides and 1 out of every 6 times the boat flips over and somebody gets hurt or dies. Like they'd go out of business immediately. That would mean, what, 30 times a day somebody's getting hurt? No, don't get on that boat. Like we got an elevator problem like this. I'm telling you ahead of time, there's an elevator problem where you get on an elevator with a whole bunch of boxes. If there's any chance at all that elevator is going to crash, don't get on the elevator. So here we would write this up. There's a 16% chance this boat's going to flip. We're going to go over the 800 pounds. Okay, now, by the way, remember here, they got the wrong answer. You know what they did? They made the common mistake right here. They used the wrong standard deviation. When you're finding the z-score in these sample problems, you don't use the population standard deviation. Use the sampling distribution standard deviation. Sigma divided by square root of n. If you've got a sample, divide by square root of n. Okay, we'll go through this one quicker. It's essentially the same problem. So pause and read. Okay, our population here is eggs. So we're going to say let mu be the mean of eggs in grams. I got an extra credit opportunity for everybody here. There's something scientifically wrong with this question. I'm going to ignore it and I'm going to move on. First person, I think I offered you this before on a different problem. First person that can identify what's wrong with this problem scientifically, send me an email, I'll give you an extra credit point. Okay, so there's our population. We're told that the population mean is 56 grams and the population standard deviation is 4.8 grams. Then I have a sample, I'm doing a dozen, sample size of 12. I want the probability that a dozen of them weigh over 690. I need to know then, how much does each one weigh? What's the sample average? So that's the same as the probability that my average weight is more than 690 over 12. 690 was the total, not how much they each weigh on average. $57.5. So that's the probability. My sample mean is more than, I already forgot, 57.5 grams. Okay, again, we're supposed to check all the conditions, but I'm going to skip that. I'm going to skip writing out the model. We do need to find our standard deviation, though. That's sigma divided by square root of n. So 4.8 divided by square root of 12. $1.39. That's also in grams. Okay, then we draw our picture. Right in the middle is the population mean. I want to be 57.5 or above, right? Way over, right? I want to make sure I have my direction right there. So I shade above, find my Z, same steps every time. Draw a picture, find the Z-score, normal CDF. Got to use this standard deviation, though. Minus 56. Hit enter, then divided by 1.39. Look, I'm getting a reasonable Z-score here. I'm not getting a Z-score like 700. Let's call that 1.08. And then normal CDF. Smallest Z-score I shaded up to largest. %. And again, I would write that as a sentence. Okay, in here, there are also some good linear regression problems. Make sure you know how to do your count, use your calculator to do linear regression. Make sure you have diagnostic turned on your calculator. Put this in your midterm. I might forget to tell you this again later. In your cheat sheet for the midterm, make sure you put this in there because they're going to clear your calculator. When you get to the testing facility, they're going to clear the memory. And then you might have to, depending on the model of your calculator, turn diagnostic back on. So to do that, let me clear. I'm going to go into catalog right there. Second, 0, and all the way to diagnostic on. Not off, on, until it says done. Hit enter until it says done. Otherwise, the calculator won't give you R and R squared. So here we would type all of the carats into X because carat is going to be our explanatory variable, and then price will be our response variable. So we type all of these into L1, all the prices into L2. The calculator then will spit out the model for us and all of that. And then you can read all the answers down here. Don't worry about question 11. We've never done residual plots, so don't stress about number 11. But make sure you understand all these answers. Make sure you understand how to interpret slope and y-intercept. Y-intercept always confuses people. Okay, one last thing for today. The different sampling techniques. Going to be on test 2, it's going to be on the midterm. Make sure you know the difference. We have 5 different sampling techniques. You got to know them all. We've got simple random, convenience, stratified, cluster, and systematic. So the ones people usually get messed up are cluster and stratified. Cluster, you talk to entire groups. You put everybody in a group and you sample entire groups. Stratified, you put everybody in a group and you take a small sample from each group. You talk to people from every different group. Systematic is you follow some kind of mathematical pattern. Convenience is you just ask whoever happens to walk by. And simple random samples, you put everybody's name in a hat and randomly choose a bunch. Okay, so let's look at these. So everybody's in a group. You've separated everybody into groups, and those groups share some kind of common characteristic. And then you talk to an entire group. So everybody's in a group, and I randomly chose one of the groups and talked to everybody that is a supervisor. That's clustered. I've clustered everybody's in a group. That group is supposed to look like the entire population, so that I get a sample that looks like the whole population. Here in B, every 4th person. So I'm standing there, and every time somebody walks by, I'm counting 1, 2, 3, 4, a sample yet. 1, 2, 3. You get the point. That's systematic. I'm following a system. Here, I put everybody in those same groups as before, but now I talk to 10 people from each group. That's stratified. And then here, I give everybody a number and have a computer randomly choose 40 numbers. That's a simple random sample, SRS. If I added in part E here, I stand out in front of the building and talk to the first 40 people that show up to work. That would be a convenience sample. And it's probably going to be a bad sample. Whatever it is I'm trying to study, people that show up early to work probably don't look like the whole population. Okay, I will upload this document here in the announcement when I post this quiz that goes with this video you're watching.